to introduce our first speaker of the day, Tejas Dinkar. Tejas will be speaking on being RESTful over GraphQL. Tejas is a full-stack engineer at Jiva with over a decade of experience in multiple domains. He is a software craftsman who enjoys learning new ways to solve problems. He loves to play with Clojure, Ruby, Golang, and Node.js. Today, he is here with us to share his knowledge on the benefits of REST GraphQL, which covers caching, error handling, discoverability, and documentation. Please welcome Tejas to the stage.
I have a mic. Hey, can everyone hear me? Okay, great. Thanks for that introduction. My name is Tejas. I work at Jiva AG. We are a farmer services platform, and if you'd like to know more about us, we have a booth over there. Feel free to catch us in the break. So I added this slide just to check if the clicker is working. It has a mind of its own. I'm really sorry. It seems to be moving slides even when I don't press it, so tell me if it's changing and it doesn't seem like it's right. Before I get started, I just actually want to thank the organizers of RUBYCONF. It's been I think 3 years since my last conference in person, and these organizers don't get any sleep at all. I was speaking to Prathamesh, I think at just over midnight, and then at 6:30 in the morning again I got calls telling me where to drop over the stuff. So please, a round of applause for the organizers, and please let them get some sleep. I kind of feel like the organizers are a little bit more robot than humans, but for the rest of us humans, we like to engage in a couple of classic arguments that have gone on since the beginning of time. First of all, do I want a little bit of sugar in my sambar? Yep, the answer is always yes, I do. I do want a little bit of sugar in my sambar. Coming to stuff that programmers like to argue about, let's talk about this. Do I like spaces or do I like tabs? Once again, there's only one correct answer. And I think I remember which one I put. And coming to GraphQL and REST, right? These are two sort of, are they opposing philosophies? My take is actually, they can actually learn a little bit from each other. Yeah? GraphQL and REST are actually kind of orthogonal concepts, and we can kind of get the best of both a little bit. Right? So before we get into it, let's talk a little bit about what people mean when they talk about REST and what people mean when they talk about GraphQL. With REST, if you ask two programmers what REST means to them, just be prepared for 3 different answers. No one seems to be able to collude on what REST actually means. But for most people, it's some form of the following. You leverage existing HTTP mechanisms like verbs and status code, which makes RESTful APIs work really well with HTTP infrastructure, like caches or reverse proxies, stuff like that. Everyone knows that get is for reading a resource, put and patch are for partial or full updates of a resource, and use delete or post to kind of create resources. In particular, Ruby has been very forward. Ruby on Rails has been very forward with its concept of resources, right? Which is you model your domain as a simple as a bunch of simple operations on top of resources. Oh man, this is really going by itself. Okay, wait. I'm just going to take this out. Yeah, so you kind of model your domain as simple CRUD operations around resources, where CRUD here is create, read, update, delete. Right? It just helps you easily manage your APIs, and of course, ensure that your services are stateless. Talks about your HTTP request should be sufficient, and there should be no hidden context that's not there in the HTTP request for sort of a response. So why did GraphQL even become popular when the REST world was sort of so well established and stuff like that? GraphQL sort of had a very the sort of exact opposite approach over here. It was like a single endpoint for all resources. And it was very optimized for fetching exactly the sort of data that you actually wanted, right? Overfetching, underfetching are, which means to say that you might need 3 fields from an object, but a REST API might give you all 20 fields that are in that, and that was something that the designers of GraphQL felt was not as great. GraphQL also has strong types. So you can be sure by reading schema what's there, and it has an ecosystem of discovering and describing APIs. So I'm going to spend the beginning of this with a little bit of an introduction to GraphQL Ruby. I'm not going to take more than 2 or 3 minutes on that. But let's look at what a typical GraphQL request actually looks like. Right? So I'm trying to fetch. Whoa, now this is not working. Oh, I need to be closer here. Yeah, so I'm trying to fetch a bunch of posts sorted by the latest post first. A post has a title, so that's definitely a field I'm interested in. But every single post is also associated with an author, right? And an author has a name and a picture. And every single author works at some sort of company, and that company has a name. So with GraphQL, I can kind of specify that these are the things that I want. And these are the exact fields within these nested entities that I care about. And GraphQL makes sure you only get that sort of data. And this really avoided the following problems that you would have with a REST API, for which the solutions would typically be either avoid making multiple calls for the same data, where maybe you make one call, get a bunch of blog posts, make a second call, get a bunch of authors. And you avoid awkward you don't need the need for a BFF anymore, like a backend for front end, where you would just call like 4 different APIs and then kind of munch that data together. Kind of can avoid that altogether. And this one in particular, I've done every single company that I've built a REST API, where you pass in and fields equals, and then you pass in a bunch of different fields that you're interested in, and that itself goes on and sort of on. Now, I know the question that you all will be thinking, hey, does GraphQL, especially if you're using something like Ruby GraphQL, does it just load up all the data and just strip down the final response so you only get certain fields back? What is this just a massive n+1 query to fetch your entire graph? So the answer to that is actually no. And this is actually built right into Ruby GraphQL with the concept of data loaders. Let's look at how this sort of works. I have a method over here called getPosts, and it tells me that I say that this returns a type of post, and getPost is very simple. It just loads all my posts from the database, very simple Rails, right? My post object is defined as having a title and an author, right? Again, nothing simple. Author in particular, you can see, is another GraphQL type, so I'm specifying it this way to Ruby. But here's where the magic actually happens. If I didn't add any function, for loading the author, what Ruby GraphQL indeed would do is that every time you say post.author, it would make a query for that author. This is going to be ridiculously slow, right? Because if you have 10 posts, every time you call .author on each post, it's going to make a query. So that's 10 plus 1, 11 queries that you've been making for this data. So Ruby GraphQL actually uses fibers for this very effectively. You can basically make this function where you basically say an author, you use this data loader and you load author.id at the bottom. And what it actually does is it actually queues up this many posts, and it says, I need to queue up these 10 authors to be loaded from the database later. And then what you have to do is provide it the actual data loader. That gets a function which you can get all the IDs in one shot. You can load all the data up in one shot, and then return it all in a single result. So this makes it so that your 11 queries has just come down to 2 flat sort of queries. And don't forget to test it. There is, you can actually write tests around these types. Actually, this library was something that was put out by my colleagues at Jiva, but it's available in the gem repository. You can create an object and you can assert that it's correctly loading the right data from the database. So what can GraphQL actually learn from REST, right? So for me, there's still a couple of things that are non-intuitive or things that GraphQL still kind of learn. The first is, how do you actually work with these HTTP caches and the rest of the HTTP ecosystem, right? It's great that you, I'll talk about that in a second. And the second is what I would call sort of this no-guessing API, right? Given an architectural style, you know exactly where the endpoint is in a REST sort of system. In particular, if it's built using on the rails, you generally know exactly where the endpoint would be, and you have uniform interfaces, for errors and results. That is status codes and some sort of format. Let's talk about caching first. The problem with GraphQL is that most requests sort of look like this. You post to /GraphQL, you send it a query and a bunch of variables behind it. Typically, this is over a post because this is a typically the queries can get very large and you may have many different variables. So there's a module called Apollo automatically persisted queries, which basically turns this sort of request into this, right? So what you see over here is rather than hitting a post API, you say get /GraphQL, passing in a query hash and sort of that post ID. It's a little bit more complicated than that, but just for simplicity's sake, this is how that works. You can see that this query or this request is easily cacheable by Varnish or Nginx or any other CDN that you might have in front of your API, and so you can actually use this to cache, right? So let's look at how this actually works. I'm going a little bit into the details, and I've borrowed this slide from the Apollo documentation. What basically happens is that the first time you're trying to make a query, the client sends a hash of the query to sort of execute to Apollo server. Apollo basically says, hey, you know what? I don't have this persisted query in my database, so I'm basically returning an error. And then the client sends the request again with both the hash and the query. This time it says, OK, fine, I'm going to execute the query. I'll return you data, and I'll store the hash for next time. So the next time that it tries to make a query, it finds it in the database, and it can be served directly from cache. Do you need to implement this yourself? No. There's two ways to sort of get this functionality. There is a gem that does this for Ruby. It's called the GraphQL API. It is actually, it's pretty well maintained, and it uses Redis to sort of store the queries. But what we actually do is we've been fronting our GraphQL endpoint with Apollo, so that you can get some of these sort of functionalities as well. Like for example, with the cache control directive, which lets you actually cache things, as well as a few other sort of benefits. So that's definitely a call that you'll have to take at some point, is that do you want to sort of expose your GraphQL endpoint directly from Rails, or do you want to sort of front it in front of Apollo? There are, of course, more traditional ways that you could do caching, using your loaders, but that's not exactly something that's very interesting to talk about. It just works. Okay, so coming to discoverability. I think that's the next important thing that it's worth talking about when we're sort of contrasting the approaches taken by both like a RESTful API as well as GraphQL. The way I look at it, there's sort of three different things that you want to sort of cover, right? So the first is, if I know a resource if I know that there's a resource of a given type, can I actually guess where that resource is? In particular, Rails's flavor of REST kind of makes it very clear. You like post to / blog post to create one. You get on the plural version to get a list, an index, and you give an ID to get a single one. This makes it very readable to machines, but maybe not as readable to humans, for which GraphQL does have like schemas and stuff. The other thing that's sort of relevant is what fields and connected entities are there available for a given response. So, we saw in our example that a post has a title and an author. And so the question is, what can I sort of do next? The answer to all of these is the GraphQL schema. And there are great tools. I was pretty shocked I've seen so many people who actually work with GraphQL, but have actually never used something like GraphQL Explorer, GraphQL GraphQL Playground. I think this is GraphQL Playground, if I'm not mistaken. But what you can actually do is you can actually visualize the entire schema. GraphQL has inbuilt into it sort of meta APIs, which tells which gives out information around what are the different types in the system, what are the different links between them. And this is something that I feel is a little bit underused by the community. Beyond this, I think the lessons from building RESTful APIs still apply to when you're building GraphQL, right? I've seen so often, in a GraphQL API, there's many different functions for what you would call an index of posts on Rails, right? You get posts, get all posts, list posts. I've seen so many variations of this, even in the same API. And usually this is bad, especially when you're kind of going across different entity types. You might have posts, which, something, and get all authors, right? I don't really have a suggestion over here, but just pick any one, right? Just don't do all of them in the same API. You probably want to sort of pick one standard and then sort of go with that, right? I think the lesson of modeling your API as a set of sort of CRUD operations, I think that's still valuable when we are talking about GraphQL. The next thing I want to just quickly speak about is consistency, right? Use arguments wherever possible in GraphQL instead of creating new APIs, right? You would do this when deciding a RESTful API, you might do posts, latest posts, and popular posts. I found that, especially in GraphQL, because you can pass an enum as an argument over here, this very much more accurately or sort of describes an API, and it's also easier to sort of visualize an API in the Explorer, because you'll know that if I'm getting posts, I can pass in either popular or latest. And I think that's something that's incredibly valuable. Okay, and coming to the last thing that I was hoping to talk about over here is error handling. And before I get started, I want to get the joke out of the way. Yes, GraphQL, quite often you will get a 200 status OK with an error in the response. I know that it's a big meme online, but that's what it is. However, I'm kind of OK with this, because in my opinion, GraphQL tries to do more than RESTful APIs, and therefore the error handling is actually proportionally more complicated. Let me give you an example. Here's a GraphQL query. Like in the query, you can actually have two sort of top-level fields in a single query. So GraphQL doesn't stop you from doing that. Let's say that I have a query called getPosts, and I'm fetching all the latest posts and all the popular posts, right? Let's say that the first part of this entirely succeeds, and the second part, let's say while loading the author, that fails, right? Maybe I'm returning 10 popular posts, and author number 3 sort of fails. So you really need to figure out what you actually want to see in the error over here. Do you want to replace this bit with an error, where maybe the post number 3 is still there, but the author is blanked out? Do you want to replace this with replace the entire post with an error? So you have post 1, 2 working, post number 3 is an error, post 4 onwards is working. Do you want to replace all the posts in this particular high-level API? Or do you just want to fail all the entire request? And while REST sort of, throwing an exception in REST sort of chooses this for you, this is theoretically an answer you would have to make when designing an API, a RESTful API as well. The typical way you would do this in a RESTful API is just throw an exception and return either a 400 or 500 depending on what the situation is. So let's actually take a look at this error. So this is the kind of error that would fail the entire sort of request, right? You would get like a field, maybe this field doesn't exist, or something like that. And you can see that the default error code that GraphQL Ruby sort of gives you is pretty mature. It actually tells you this is the part of the query that actually failed, this is the reason for it, and you probably get some stack trace. By default, I think it returns to 200 OK, but you can actually change that for different actually error types so that you can be a bit more smart about that. So I saw a great blog post by Sasha Solomon, who had a great way of reasoning about this. There are some things that will fail the entire request. Uncaught exceptions, for example. requests and responses that don't match the GraphQL schema will also fail the entire request. In particular, like just remember that the response also is asserted on. So if you said something is an integer, it has to be an integer. You can't pass it null, right? You need to GraphQL validates both the request and the response to make sure it matches the schema, and that's an exception you can't catch. Every other scenario, rather than thinking of it as an error, it's possible to think of this as an alternate response, right? So this is not an error situation. It's just a response that wasn't what you would sort of expect. So let's take a look at how this alternate results works, especially if you're hoisting this at the highest level of the query, right? Now, over here, I'm basically saying that I'm trying to fetch a post, and that post can either be a post, it can be a post not found, or a hidden post, right? And you can define the union type like this in Ruby. You can say that this is the thing, and here are the possible types that this corresponds to. And the query actually looks pretty good, right? Because you can say that, hey, get me this post by ID. I would like the type name, and if it's a post, I get a title. If it's a hidden post, give me the reason that this post was hidden. And we actually tried this at Jiva, and we got some amount of success. But what we found is this got out of hand very, very quickly. So let's try to add a different type on this, right? Let's say I'm adding a deleted post, right? What has to happen is every single one of our clients, right? We have an Android app as well as a few JavaScript apps. Every single client needs to update its queries to kind of handle the new types. This isn't strictly mandatory because even the previous query would have passed because GraphQL doesn't define that you have to have every single type listed out. But if I wanted to show a message that, hey, this post has been deleted, then I definitely need to assert for this sort of type. Because GraphQL doesn't have any sort of inheritance in it yet, I believe it's being worked on currently in the spec, but it's not yet in the spec. Because there's no inheritance, I couldn't say that all types of errors have like a generic code or a message or something like that, and therefore, and only if you get the specific fields for more like sort of higher level types. And so because of this, we eventually abandoned this sort of approach because we found that this sort of ended up with a very tight coupling between our servers and our client. And we ended up with what's the most straightforward approach, which is just wrapping responses with both an error and a sort of result field. This turned out to be the simplest. This has been working for us so far. But of course, has the trade-off that now, like an error, you need to check in like 3 or 4 different places just to check where an error is, because it still could be at the it could be at the top level, it could be at the middle, it could be anywhere. So, as I'm running out of time, just some conclusions. I think that if you haven't gotten a chance to play around with GraphQL in your project, now is a great time for it. The support for Ruby is fantastic. We've been using it even. We introduced Apollo actually much later into our stack. We've been loading with just Ruby GraphQL for a long time, and it just works fantastic. It's super mature and really helps us. Even the data loaders and stuff really has helped us visualize and think about our own resources a little bit better. But just because you're using GraphQL doesn't mean that the discipline that you would have when building out a RESTful API to sort of ensure that you stay on the rails is, it doesn't mean you can just forget about that. It's important to be very cognizant about your API design no matter what, and that's true in GraphQL as well. I have some credits for the reading. These are both great posts, and that's it. I'm happy to take any questions.